Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the second part of sequences, which is how to find the nth term of a quadratic sequence. This topic is higher tier only, so if you're foundation tier, you can go back and check out the linear nth term video. This one is not relevant to you. So before we jump into answering the questions, there is a little bit of content that we need to cover first so that we understand where the method comes from. So obviously quadratics we've heard of in multiple different contexts. So you can see here at the top I've got the format of a quadratic. Obviously we're using n because we're talking about nth term and sequences. However, it's still the same format as when you would normally see a quadratic, isn't it? You'd normally see ax squared plus bx plus c, wouldn't you? And obviously a, b and c are numbers. Now I know it says plus, that doesn't mean it's always plus, okay? It could also be minus something, but just for simplicity we use plus most of the time here. So that's the format of a quadratic, and in terms of nth term, obviously we're going to use n instead of x. Now, if you'd have seen the first video on linear nth term, you will know that n represents the term number, doesn't it? So for example, that's why you can see here 1, 2, 3, 4. That's not the sequence, that's just like term number 1, term number 2, term number 3, term number 4, obviously ... So because we know the format of the nth term expression is going to look like this, when I substitute 1 as n, obviously that's where the a plus b plus c comes from, isn't it? Because if I were to write it over here, a and then times 1 squared plus b times 1 plus c, that just simplifies to a plus b plus c, doesn't it? So that's where this comes from. So what we're saying is the first term in any quadratic sequence is basically a plus b plus c. Now, because we're trying to find the quadratic nth term, we are trying to find a, b and c, aren't we? We need to know what is a, what is b, what is c. Now, if you think about equations, you can't solve an equation if there's more than one letter, can you? For example, when you've done simultaneous equations, when you had both x and y, you needed two equations. So we can't jump in and solve this straight away because, well, a plus b plus c equals whatever they've given you as the first term. Yeah, but I don't know what the split is, do I? So we have to hold fire on that. And then you can see, for example, the second term is obviously n would be 2. We don't know what the term is because we haven't looked at a question yet, but it's the second term in the sequence, isn't it? And then if I substitute that in, I've got a times 2 squared plus b times 2 plus c. And you can see that's where I get, obviously 2 squared is 4, so 4a plus 2b plus c. That's where this one comes from. And so on. So you can see where that comes from, okay? These blue expressions represent the actual terms, okay? So 1, 2, and 3, 4, 1, 2, 3, 4 are the term numbers. So the first term, the second term, the third term. A plus b plus c, 4a plus 2b plus c, and so on. Those are the actual terms. Okay, so these are the actual terms that they will show you. Obviously, we need to know that the first term is made up of a plus b plus c. Now, obviously, I've given you all this context. You don't actually need to memorize these bits, right? Okay, so don't worry. You need to just know the first one. But what I want to show you is, that's the reason why these letters and numbers are there, okay? I've just substituted in n as 1, n as 2, n as 3, and so on. What you are going to do is you're going to have the terms in front of you. You're going to find two differences. So with linear nth term, we knew the difference was the same every time, wasn't it? So we just had to find one difference. With a quadratic nth term, the difference is not the same every time. So you can see I've basically done the second term minus the first term. That's the difference, isn't it? If I were to write it over here, 4a plus 2b plus c, subtract a plus b plus c, do you see that's where I get 3a plus b, and obviously there's no c. That's where this comes from. And then the same, if you were to find the difference between these two, I get 5a minus b, and there's no c again, the c's just keep cancelling out. And here, 7a plus b is the difference. So you can see the first difference, they're not the same as each other, they won't be. You will work this out in physical numbers, okay? They won't be the same difference. So you then have to find the second difference. So then, work out the difference between the first term. Between the first difference, okay? So 5a plus b minus 3a plus b is 2a. Every time it will be 2a. So basically, I know this is a lot to take in because we haven't got a context of the question or anything. It's quite hard to understand what I'm on about until we apply it to a question, but I need to explain where these letters and numbers come from in the first place. The bits you need to memorize, okay, is that the first term, the actual first term in the sequence, is the same as a plus b plus c. The first difference, okay, so the difference between the first two terms is equal to 3a plus b. And finally, your second difference is equal to 2a. You don't need to worry about the rest of this, but I've just obviously had to put it there for some context. You need to memorize these three things and what they match up to. So we need to know 2a, 3a plus b, and a plus b plus c. So there's a little bit to memorize, okay, but once you've memorized it, it's fine. Now, as I said, we're basically having to find out what is a, what is b, what is c. So you can see that we would have to start down here, wouldn't we? Because, as I said, you can't solve an equation if there are multiple different letters. You can only solve it with one letter. So we can start here with the 2a. That's only one letter, isn't it? Okay, that probably doesn't make a lot of sense, but screenshot this bit if you want to keep it. We're now going to apply it to an actual sequence, okay? I'm going to show you exactly what I mean. Don't worry, all will become clear, okay? So, find the nth term of the sequence. A lot of the time they might tell you that it's a quadratic sequence. If they don't, you can kind of tell if it says find the nth term, and then you can see that it's not the same difference every time. Then you're like, well, that's not linear. So it's probably a quadratic one. What we're going to do, this is literally what you're going to do in the exam, okay? As I said, this is like term 1, term 2, term 3, this is n, term 4, term 5. So, you're going to find the first difference. Okay, so you don't even have to write this, but I just normally write first diff. The difference between -2 and 3 is 5, isn't it? The difference between 3 and 10 is 7. 10 and 19 is 9. So you can see the difference is not the same every time now. 19 and 30 is 11. Okay. Then find the second difference. So the difference between this row. So the difference between 5 and 7 is 2, 7 and 9 is 2, 9 and 11 is 2. So your second difference, this row here, should come out as the same. The first row won't be the same, the second row will be. If it's not, something's gone wrong, okay? Now we can work backwards. So remember how I said you need to remember, let's just go back quickly, that the second difference represents 2a. Okay, so let's do that first. So this bit is equal to 2a. So I just go here and go, okay, 2a equals 2 in this case, or whatever number you get here. Do you see how that's now an equation that I can actually solve? I can go, well, if 2a is 2, a must be 1, mustn't it? If I, obviously have to divide by 2 on both sides. So I found out what a is. And as we said, the nth term is in the format of an squared plus bn plus c. So we know there's 1 in front of the n squared. Cool, we now need to find the other two letters. So let's go back here. The next one, you have to work your way up basically. So you start at 2a, then you go to 3a plus b, then you go to a plus b plus c, because as we said, you need to have only one letter that you don't know. So 3a plus b is the same as the first difference. So you have to be specific here. It has to be this one, okay? It can't be 7 or 9 or 11. It has to be the first number in this row of the first difference, if that makes sense. So 3a plus b, you literally make that equal to whatever number you get here. Okay, so that's 5. Now, I know we've got two letters here, but do you remember how we just found out what a was? Well, I can substitute that in, can't I? I can go, right, 3 times 1 plus b is 5. Okay, well, that's 3 plus b, isn't it? 3 plus b is 5. Therefore, b, I have to subtract the 3, is 2. Okay, now I've got a and b. Perfect. Now I just need c. So go back again. Now we're on to the last bit. The first actual term in the sequence is a plus b plus c. So this actual term here, okay, it can't be any of the other terms, is equal to a plus b plus c. So I'm going to write it here. A plus b plus c is equal to -2. And now that we know what a and b are, we can sub those in, can't we? 1 plus 2 plus c equals -2. So that's 3 on this side. Let's write it here. 3 plus c equals -2. And we would have to subtract the 3, wouldn't we? Which gives us -5. Perfect. Now we have a, b, and c. We can write out the nth term as a quadratic. Okay, so I'm just going to rub all this out so I can show you what the nth term is. Okay, so your final answer, the nth term, as we said, is in this format. You just sub in those numbers. So we know a was 1, B was 2 and C was minus 5, wasn't it? So I just need to write down, obviously 1n squared. Well, I don't need to write 1n squared, do I? That's just n squared plus 2n minus 5. Obviously that's not a plus anymore, it's a minus. That's your nth term. Okay, that's literally it. So if you can memorize that method, go write down the first difference, write down the second difference, then work backwards. You have to remember 2a is this one, 3a plus b is this one, and a plus b plus c is this one. If you can memorize that, it's really easy, okay? That's what we're going to do every single time. So let's try another one, because I know that's a lot to take in. Find the nth term of the sequence. So work out your first difference. So the difference between minus 9 and minus 9 is 0, minus 9 and minus 7 is 2, minus 7 and minus 3 is 4, and minus 3 and 3 is 6. Okay, we know that's not going to be the same as each other, that's fine. So we now need the second difference. Okay, now every time it is 2, isn't it? You see. A lot of the time it will be 2, but it might be something different. And then we just remember, oh, I have to remember that this one is equal to 2a. So let's see, maybe I'll put it down here this time. 2a equals 2, therefore a is 1. That's quite common. Then I go and jump up to the next one. The first difference within the first difference row is equal to 3a plus b, isn't it? So 3a plus b equals 0. But as we said, we know what a is. A is 1. Okay, so we've got 3 plus b equals 0. Well, in that case, b is minus 3, isn't it? And finally, jump up to the actual first term in the sequence. That is equal to a plus b plus c. So equals minus 9. Now we know what a is, that's 1. We know that b is minus 3. And we want to find c. It's just algebra at this point, isn't it? So 1 plus minus 3 is minus 2, isn't it? Let's draw this over here. So I've got minus 2 plus c equals minus 9. I'd have to add the 2 across, wouldn't I? C is minus 7. And then for the nth term, you just put it all together. Remember, it's in that format of a quadratic. So we know it's an squared, so 1n squared, plus bn, well, b is a negative, so minus 3n, plus c, again, c is negative, so minus 7. That's your final answer there. And if you wanted to test it out, as we said, n is the term number. So when n is 1, let's write it out. When n is 1, we'd have 1 squared minus 3 times 1 minus 7. Okay, that's 1 minus 3 minus 7. Yeah, that gives me minus 9, doesn't it? Which is the first term. So you can check it out if you want. You can double check at the end if you want to really make sure it's right. But if you just remember this, write the first difference, the second difference, then equate these 3 numbers to those 3 expressions. That's it. Okay, if you are happy with that method, if you've made a note of the 3a plus b, 2a, and a plus b plus c, have a go at this one, pause the video. But otherwise, we're going to go through it. So we're just repeating ourselves now, aren't we? First difference is actually, you can see this is a decreasing sequence, isn't it? So it's not just that the difference is 3, it's minus 3, okay, so just be careful. And if you did do our linear nth term video, you'll know that when it's a decreasing sequence, just put the minus in front. So that's minus 5, minus 7, and minus 9. Okay, second difference will come out as the same thing. So this is minus 2, isn't it, every time? Minus 2, minus 2. Now we're going to just equate it to the expressions that we have. So we know that minus 2 is equal to 2a, isn't it? So a in this case is now actually minus 1. So divide by 2, a is minus 1. Then we jump up and go, the next one is equal to 3a plus b, isn't it? Which is minus 3. Now we know what a is. We know that a is minus 1. So we've got 3 times minus 1 plus b is minus 3. Okay, well that gives me minus 3 plus b equals minus 3. So I'd have to add the 3 across, wouldn't I, to get b on its own. Minus 3 plus 3 is 0, so b is 0. In this case, that just means there isn't an n term. Okay, the middle term is not there. That's fine. And finally, we jump up to the last one, which is the actual first term in the sequence. A plus b plus c equals 8. Now we know a is minus 1. We know that b is 0. I'm going to write it, but you don't technically need to. Plus c is 8. To get c on its own, I'd have to add 1, wouldn't I? So c is 9. And then you just put it in the correct format of any quadratic, but obviously using n. The nth term is minus n squared, minus 1n squared, isn't it? Now, it's technically plus 0n, isn't it? But obviously you wouldn't write that because that's just unnecessary. And then plus 9. So it's still a quadratic because the quadratic part is the n squared, isn't it? However, you can see we don't have a middle term. That's fine. You might not have all 3 parts of the quadratic. Okay, you might not have like all of the n squared plus n plus a number at the end. That's fine. Obviously, you have to have the n squared, otherwise it's not a quadratic, is it? But you might be missing the c or you might be missing the b. That's fine. So that's your final answer for this one. Okay, this one is increasing this time, so not as confusing. But we are just repeating ourselves, aren't we? First difference. Okay, well, I'm going 2, then I've got 6, then I've got 10, then I've got 14. Okay, second difference. This time you can see it's not actually 2. This time we've got 4, but obviously it is the same every time for the second difference, 4, 4 and 4. And then we just go back and equate them. So this time we've got 2a equals 4. A is 2, isn't it? Okay, so sometimes that might happen. A lot of the time 2a is 2. Okay, then we jump up and we go, right, 3a plus b equals this number here, which is 2. We know that a is 2, so we can put in the 2 here. So we've got 3 times 2, which is 6, plus b equals 2. And I'd have to minus the 6, wouldn't I, to get b on its own. So 2 minus 6 is minus 4. Okay, b is minus 4. And then we jump up again to the first term in the sequence, which is minus 1. So we've got a plus b plus c equals minus 1. A is 2, b is minus 4. And now we can find c. So 2 plus minus 4 is minus 2 overall, isn't it? Plus c equals minus 1. So c, we'd have to add 2, wouldn't we? Minus 1 plus 2 is 1. There we go. And now we just put it all together. The nth term as a quadratic is 2n squared minus 4n plus 1. There you go. There's your quadratic nth term. So hopefully by now you can kind of see that we basically just have the same pattern every time, don't we? You just need to memorize the method, really. Some topics are more so really kind of understanding and using your logic to figure it out. And other topics within the syllabus are, look, just memorize these steps and you'll get it right every time. This is one of them, okay? So just try and memorize these steps as much as you can. Okay, hopefully you feel confident enough to try this yourself. So give this one a go, pause the video, and then check your answer. So we're going to work out the first difference. We've got here 10. Then we've got, what's that, 16. Then we've got 22. Then we've got 28. Okay. Second difference should be the same every time. So we've got 6 here, yep, and another 6, and another 6. Okay, perfect. So my second difference is equal to 2a, isn't it? 2a equals 6. So I divide by 2 and get a is 3. Then I go up to the next one, back on the first difference, is equal to 3a plus b, isn't it? Which is 10. Now I know that a is 3, so substitute that in. Okay, well, 3 times 3 is 9, plus b is 10, so therefore I'd have to subtract 9, wouldn't I? I'd have to take away 9. So b is 10 minus 9, which is 1. And finally we go up to the first term in the sequence, which is 12. So we've got a plus b plus c is 12. I know that a is 3. I know that b is 1. And c we're finding. So 3 plus 1 is 4, plus c equals 12. So to find c on its own, I just have to subtract 4, don't I? 12 take away 4 is 8. Simple as that. Obviously just don't forget to write it all out in the correct format at the end. So the nth term is 3n squared plus, technically 1n, but I'm just going to write n, plus 8. There you go. Literally as simple as that once you've got the idea of the method and you can remember it. Okay, so as I said, you don't need to necessarily remember all of the rest of this. The only things you need to remember are that the second difference is equal to 2a, the first difference, but specifically that first number as well, because you can see that the next one is different, isn't it? 5a, the next one's 7a. So the first number in the row of the first difference is 3a plus b, and the first term, again, it has to be the first term, because otherwise you'd have to memorize a different set of letters and numbers. The first term in the sequence is then equal to a plus b plus c. Okay, so you work out the first difference, you work out second difference, then you equate the second difference to 2a, you then jump back up and equate your first difference to 3a plus b and work out b, and then finally you jump up to the first term and equate that to a plus b plus c, and then I guess past 6 is writing it out as the nth term, isn't it? Okay, so those are your steps. Any of this bit, this was just for the explanation of where have I got, all of these letters and numbers from. You just need to remember these 3 that I've highlighted, okay? So that is everything on how to find the nth term of a quadratic sequence. As I said, this was higher tier only, so if you're foundation and you're still here, you don't technically need to know this. Go back and check out the linear nth term video if you haven't seen that already, because there are some really easy marks there. So thanks for watching this video. Make sure to subscribe and go and check out all our other playlists to find specifically higher tier and specifically foundation videos as well.